When programmers talk about scope, they're not talking about a tube that lets you see far away. They're referring to a region of code where a particular variable can be accessed. In other words, which part of the code can see a variable. There are two types of variables, local and global. In the previous lectures, we have generally been defining global variables. For example, when we write int I equals 3 at the top of our program, outside of any functions, I is a global variable. That means the value in I can be accessed inside any function, including setup and loop. Let's say we initialize a serial connection and immediately print the value of I. Because I is global, we can access its value inside setup, so we'll see 3 printed. Then, in loop, let's increment I, print its value, and wait 1 second. Run this, and you'll see how I is incremented every pass through the loop. This works because I is global. It can be read and modified anywhere in the program. However, in most programming, global variables are considered bad, especially when programs get large with multiple files. It can be hard to remember what the global variables are called and what they store. Additionally, because they can be accessed by anything, other parts of the program can change your variable without you knowing, something that can easily happen if multiple people are working on the code. To help with this, we can use local variables. The variables are declared in a function or loop and only live for that function or loop, meaning they can only be accessed between the curly braces of that particular code block. Let's rewrite our loop function to show an example, but leave the delay for now. At the top of the loop, write int a equals 0. Here, we've declared the local variable a and assigned it the value 0. Then, write a++ to increment a. Finally, write serial.println a to print the value of a. Remember, a is local to the loop function. What do you think will happen when we run this? Let's try it. It just prints 1 over and over again. Why? Well, because a is a local variable, it only exists when loop is called. Looking at our code, when loop is called, a gets created and assigned the value 0. We increment a and print its value before waiting. The loop function then exits, which means a gets destroyed. It no longer exists in our program. When loop is called again, a brand new a variable is created and assigned the value 0. Let's explore how local scope works in loops. First, remove the serial.println I line in setup. Replace the a++ and serial.println lines with a new variable, int b equals 2. Then, create a for loop where we print b 3 times. For, open parentheses, a equals 0, semicolon, a less than 3, semicolon, a++, close parentheses, open curly brace. Then serial.println b, close curly brace. Upload and run this. You should see the number 2 printed 3 times every second. Even though we created b as a local variable in the loop function, because the for loop is inside the loop function, we can access b within the for loop. What happens if we move our b variable definition to within the for loop? A new variable named b will be created and set to 2 through each iteration of the for loop. This program will run in the same fashion as before. However, b is local to 1 iteration of the for loop, which means that it cannot be accessed outside of the for loop. If we write serial.println b outside of the for loop and try to compile, we'll get an error. b was not declared in this scope. That's because b is created and destroyed during each iteration of the for loop. It doesn't exist outside of the for loop. We consider b to be in scope for each loop iteration and out of scope everywhere else. Now let's really test scope. Underneath our a variable definition, write int b equals 5. Now there's one more variable named b in the loop function. What do you predict will happen when we run this? Try it and see. We see 2 being printed 3 times followed by a 5. Why? Well, it turns out we can declare multiple variables with the same name so long as they are in different scopes. In the loop function scope, we declare a variable named b with the value 5. In each run through the for loop, we declare a new variable named b with the value 2. However, these two are not the same variable. The b in the for loop is a brand new variable that we create, and it only exists inside the for loop. The compiler uses whichever variable is most local to the code block. That means in the for loop, the b that is set to 2 is the most local. It was declared most recently in the current set of curly braces. If the compiler can't find a b in the current set of curly braces, it would then look outside to the next set of curly braces, which would be the loop function in this case. If we had not declared a b in the for loop, we would use the b from the loop function. If there was no b in the loop function, the compiler would then look to the global scope to see if it could find a variable named b. If it can't find one there, the compiler will fail, telling us that no b was declared. Hopefully, you have an idea of how scope works in C. While this is a useful exercise, and I encourage you to play with declaring variables in different scopes, it is generally not advisable to have variables with the same name. There are plenty of words and phrases you could use, so why try to confuse yourself or someone else who might be trying to read your code? To make this better, we might use for_b in the for loop to avoid confusing b with the loop function's b. The last part we need to talk about is formal parameters. Formal parameters are declared when you write a function, and they are treated as local variables within that function. Let's see how this works with an example. Change int a equals 0 to int a equals 3, and delete the for loop and serial.println. Let's create a function that adds two numbers together. Silly, but it shows how we can use parameters as local variables. Below the loop function, write int add, open parentheses, int x, comma, int y, close parentheses, open curly brace. On the next line, write serial.printx, followed by serial.print the string plus sign, then serial.print y. Return x plus y, close curly brace. Here, we created a function that takes two integers, x and y, and prints the value of x, the character plus the value of y, and returns the sum of x and y. In this, x and y are formal parameters, and once inside the function, x and y exist as local variables, which means we can access them as needed. Back in the loop function, write serial.println add, open parentheses, a, comma, b, close parentheses, under our b definition. Note that we are printing the return value of our function, which is a totally valid thing to do because the return value is simply an integer. It would be no different than printing a real integer or the value of a variable. Upload this program and open a serial monitor. You should see 3 plus 5 followed by 8, the sum of 3 and 5. What do you think would happen if we tried to print the value of a in our add function? The compilation fails because our function doesn't know about a. Even though we call the add function in the loop function where a is a local variable, we could potentially call the add function elsewhere, like in setup, where there is no a variable. As a result, the add function has no idea what a is. It can only see the arguments, whatever values were passed in through x and y, as local variables. Additionally, it can see and access any global variables, such as I, which we've left defined at the top of our program. I hope this helps give you an idea of how and where to define variables in your program. I generally recommend using local variables unless you really need to use a global variable. However, they might be considered bad, but when it comes to writing programs for our Arduino, they're generally small enough that we can get away with some global variables, and it really helps. For example, if we need to remember a value between runs of the loop function.